Hi, and welcome to this video on proving lines parallel. We've been talking about uh, what determines parallel and perpendicular lines and also the slopes of those lines. Now we want to recognize the angle pairs that occur within parallel lines. We also want to be able to prove that those lines are parallel. So we have this postulate here, postulate 3-4. If two lines are cut by a transversal, so that corresponding angles are congruent, then the lines are parallel. So essentially, the reverse of what we've talked about before, or I should say the converse, we know that if you have two parallel lines cut by a transversal, you know that the corresponding angles such as 1 and 3, 7 and 5, 2 and 4, 8 and 6, you know that those are equal. Now we're just going back the other way and saying if I have equal corresponding angles, then I have to have two parallel lines with a transversal cut through it. So let's go ahead and look at our next postulate, postulate 3-5. If given a line in a point that's not on the line, there's one line through the point parallel to the other line. So if we had line M and point P, we know that this very line right here is the only line that's parallel to M. And we know that that line exists based on this postulate. Here's a bunch of postulates we want to look at. We have the alternate exterior angles converse. So if two lines in a plane are cut by a transversal, so that a pair of alternate exterior angles is congruent, so we're talking about 1 and 3 here, the two lines are parallel. So all of these again are just converse of the postulates we've discussed before. We've talked about, let's suppose we had two parallel lines with a transversal, the alternate exterior angles are congruent. Now we're saying if we have alternate exterior angles that are congruent, we know we've got two parallel lines cut by a transversal. So we know we have that situation also if we have consecutive interior angles that are supplementary, they add to 180. We know that we have two parallel lines with a transversal if we've got alternate interior angles that are congruent. And finally, if two lines are perpendicular to the same line, so for instance if P and Q are both perpendicular to R here, that means P has to be parallel to Q, and we can sort of prove that based on the fact that they are both, these corresponding angles are right angles. So identifying parallel lines, given the fact that 1 is congruent to 3, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. And I think based on what we had just said, we know that these are corresponding angles. So given the fact that these are corresponding, I think we can conclude that A and B are parallel. And that was the corresponding angles, the converse of the corresponding angles postulate. So let's look at this question. Given angle 1, the measurement is 103, and angle 4 down here is 100. Is it possible to prove that any of the lines shown are parallel? If so, state the postulate. In this case, we do not have either equal or supplementary angles. They're 100 and 103. So that immediately tells me that A and C cannot be parallel. Those again are alternate interior angles. So by the converse of that theorem, since they're not congruent, they cannot be parallel. So go ahead, pause the video for a second, see if you can come up with an answer to this question and answer it in the multiple choice. Now I'll go ahead and try this one. Make sure you pause the video so it doesn't disappear on you. All right, so moving forward, let's look at using these angle relationships we've learned. We want to find the measurement of angle Z, Y, N, this angle right here that's labeled 7x plus 35 degrees, so that PQ is parallel to MN. So these are on opposite sides of the transversal, so they're alternate. They're also outside the lines, so they're exterior. Alternate exterior angles are congruent. And remember, if you ever forget that, just look at them. They look pretty equal, so common sense should sort of hint you toward the fact that they're congruent in case you forget. So we're going to set 11x minus 25 equal to 7x plus 35. Let's get all of our like terms on the same side, so let's subtract 7x from each side. Let's also add 25 to each side. We're going to get these to cross out, and we'll have 11x minus 7x, which is 4x, equals 35 plus 25, which is 60. Let's now divide both sides by 4. The 4's cross out to give me 1x equals 60 divided by 4, which is 15. So we can say that x is equal to 15. If we want to know the angle of ZYN, we'll plug that back in. 7 times 15 plus 35 is our angle measurement. 7 times 15 is 105. And 105 plus 35 is 140. So our answer is 140 degrees. Now I want you to try this problem, finding x so that line GH is parallel to RS. And now we're going to talk about this construction application. Here we have a window where the diamond grid pattern is constructed by hand. Is it possible to ensure that the wood pieces that run in the same direction are parallel? If so, explain how. If not, explain why not. Basically, if we were to measure the corresponding angles formed by two consecutive grid lines, so for instance, maybe this line and this line, and we cut a transversal through the two lines, like this one for instance, if we measured two corresponding angles like this one and this one, we should see that they are congruent. And if they are congruent, just by our converse of the corresponding angles postulate, we should be able to prove that those are parallel lines. So in other words, we know that we can measure the distance between two spots, but this is also another way to ensure that those lines are parallel. So now try this question here. I'll go ahead and make sure you pause the video. Alright, so that concludes our lesson on proving lines parallel. Thanks for watching.